This is trigonometry section 6.2. Today we're going to be talking about trigonometry of right triangles, if I can speak. So we have our 6 trig functions. We've talked about these numerous times. So we have sine, cosine tangent, cosecant, secant, and cotangent. And then we know the different ratios for that. So this was the SOHCAHTOA, or the Oscar had a hairy old ant, depending on whichever way you remembered it. Eventually we're going to kind of move away from that, but this is what we're going to do today. So it does have a little triangle here where it'll show you whenever you have this angle theta, opposite is the side that's not touching it. So adjacent does touch the angle, but it's not the hypotenuse. The hypotenuse is the longest side, but that's something that's common. You've known since we've talked about geometry. So we're going to start out with just finding the exact values of these trig functions based off of theta. So we're going to have to find all 6 of them. You do have to write this out. So you do have to put sine of theta, cosine of theta, tangent of theta, and this is how I'll always write it. Cosecant is the inverse of theta, so I always write it opposite. Secant is the inverse of cosine, so I write it opposite it, and then cotangent is the inverse of tangent, so I'll write it opposite that side. So whenever they want you to find the 6 trig functions, you do have to go ahead and write this out before you start. So when we begin with this, if we want sine, we know sine is opposite over hypotenuse. So the opposite side of sine is 7, hypotenuse is 25. So we'd have 7 over 25. Cosine is adjacent over hypotenuse, so adjacent does touch, so we'd have 24 over 25. And then tangent is opposite over adjacent, so we would have 7 over 24. Now the reciprocals, you don't have to go ahead and go back through and figure them out. All you have to do is flip them. So here you're going to have 25 over 7, 25 over 24, and then 24 over 7. Okay, so if we look at our next one, the first thing that you have to do is figure out what the hypotenuse is. So we would have 8 squared plus 15 squared equals the hypotenuse squared, or you can do c squared because it's the Pythagorean theorem. So then we would have 64 plus 225, which would give us the square root of 289 for the square root of h. So we get that h equals 17. And that was a really, really abbreviated form of the Pythagorean theorem, but you should be very comfortable with it already. So if you aren't, you'll want to make sure that you stay after for tutoring or something so you can ask questions about that. And then we're just going to go ahead again and do our 6 trig functions. So sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and then cotangent of theta. So sine, again, from this angle theta, opposite over hypotenuse, so 15 over 17. Then adjacent over hypotenuse, so 8 over 17. And then opposite over adjacent, so 15 over 8. And then again, we just do the reciprocals of that to figure out our cosecant, our secant, and our cotangent. And you go ahead and do the next one down here. Okay, so again, you have to do the Pythagorean theorem with this one, but this time we don't know one of our sides. So we get the square root of 15, but then we still go ahead and stick it into sine, cosine, tangent. Now, you do have to realize if you end up with a square root in the denominator, you have to eliminate it. So that's how we get this 7 times the square root of 15 over 15. It's also how we get 8 times the square root of 15 over 15. So those would be your 6 answers for this. Now on our last one on this page, they want us to find a few different things. So we want sine of alpha and cosine of beta. The first thing that you'll want to do is go ahead and figure out what this side is though. So again, you'll have to do the Pythagorean theorem for that. So you would have a squared plus 4 squared equals 7 squared. So a squared plus 16 equals 49. And when we subtract our 16 from both sides, we get 33. So we're going to take the square root of that. So a is the square root of 33. Okay, so on the first one, they want sine of alpha, which we know sine of alpha is opposite over hypotenuse. So sine of alpha, 4 over 7. And then cosine of beta, which we know is adjacent over hypotenuse. So now this is the adjacent, that's hypotenuse. So that also gives us 4 over 7. And you're going to see this to continue to happen. So you go ahead and figure out B and C, and I'll come back with your answers. Okay, so these are the other answers you would have gotten. You would have had 4 over the square root of 33 here, but again, we don't want to have square roots in the denominator, so that's how we get our 4 times the square root of 33 over 33. Same thing happens with our secant and cosecant, so 7 times the square root of 33 over 33 is what you would have gotten for both of those. Okay, so now they want us to find this side labeled x. So the first thing that you have to do is figure out what you have. So we have this angle, 45, and then we have the opposite and the hypotenuse. So opposite and hypotenuse is sine. So we would have sine of 45 degrees equals, we know the opposite is 12 and the hypotenuse is x, and then we have to solve for x. So we'd have to multiply both sides by x, divide both sides by sine of 45, which just switches these things. So we would have x equals 12 over sine of 45. Now we know what a sine of a 45-degree angle is. We always call sine of 45 the square root of 2 over 2. It's actually 1 over the square root of 2, but again, we can't have the square root of 2 in the denominator, which we worked through this, so instead we have to multiply everything times the square root of 2, which is how we get the square root of 2 over 2. But here, it'd be most helpful to just go ahead and leave it as 1 over the square root of 2. So we would have x equals 12 over 1 over the square root of 2. That's helpful because we're going to have to multiply by the reciprocal. So we're going to have x equals 12 times the square root of 2 over 1, which is just 12 times the square root of 2. So if we go ahead and look at the next one, here we have the opposite and we have adjacent. So we know opposite and adjacent is tangent. So we would have tangent of 30 equals the opposite, which is 4, the adjacent, which is x. Now again, these things are just going to switch positions, so we're going to have x equals 4 over our tangent of 30. But we know how to figure out our tangent of 30. We know at 30 degrees we have the ordered pair, the square root of 3 over 2, 1/2. This is cosine, this is sine. So tangent is sine over cosine, so we're going to have 1/2 divided by square root of 3 over 2. Can't divide fractions, so instead we're going to multiply by the reciprocal. So those will cancel out, and we're left with 1 over the square root of 3. Again, can't divide fractions, so instead we're going to multiply by the reciprocal. So we're going to have 4 times the square root of 3 over 1, which is just 4 times the square root of 3. Okay, so you go ahead and try and do the next. So if we look at this one, we have sine. Now this isn't an angle that we know, 53 degrees. It's not perfect. So we'll go ahead and switch them, but then now you just stick that into your calculator. So you'd have 25 divided by sine of 53 to get your 31.0 or 0.30339. Now the one thing about this, whenever you're working with these sine, cosine, tangent, You want to make sure that you're in radians whenever you're trying to solve for this. If you're in degrees, it's going to give you an incorrect answer. Sorry, I said that exactly backwards. We actually do have degrees here, so you want to make sure whenever you do the sine of this 53, you're in degrees. It's whenever you're given radians and you're finding the sine, cosine, and radians, then you'll have to switch back and forth between that. But we'll talk about that more in class. Just anytime you have your degree, make sure you're in degrees. If it doesn't have degrees, make sure you're in radians. Okay, so if we want to express x and y in terms of the trigonometric ratio of theta, then we would have first, if we figure out our x, we have the opposite and we have the adjacent. So when we have opposite over adjacent, we know we have tangent. So we would have tangent of theta equals x over 4. So if we want to get x by itself, we just multiply both sides by 4. So we would have 4 times the tangent of theta equals x. When we look at our y, we have adjacent over hypotenuse, which is cosine. So we would have cosine of theta equals, and again now it's adjacent over hypotenuse, so 4 over y. So now we have to get y by itself. So we're going to divide both sides by cosine, multiply both sides by y. So we would have y equals 4 over cosine theta. But we know 1 over cosine is just secant, so we can go ahead and just change that to y equals 4 secant of theta. Okay, so now we want to sketch a triangle that has this acute angle of 90 degrees, or acute angle of theta, and then it is a right triangle. So we do know we have this 90-degree angle. We know cosine, which is adjacent over hypotenuse, so 9 over 40. And we have to express our other trig ratios. Since we do know that this is a right triangle, we can still do Pythagorean theorem. So we would have x squared plus 9 squared equals 40 squared. So when we go ahead and do the Pythagorean theorem, we end up with 7 times the square root of 31 for this side. So then we have to go ahead and figure out sine, cosine, tangent. Well, we know cosine because that's what was given to us. So we know that that's 7 times the square root of 31. Okay, so then we just go ahead and do sine, which is opposite over hypotenuse, so 7 times the square root of 31 over 40. And then opposite over adjacent for our tangent, so our opposite again, 7 times the square root of 31 over 9. And in my rush to get this done, because I'm running out of time, they gave us cosine, which cosine we know is 9 over 40. So we'd have cosine there as that instead of that 7 times the square root of 31. That 7 times the square root of 31 is just that side. So now we're just going to go ahead and do the reciprocals of these. So cosecant would be 40 over 7 times the square root of 31, which we would have to simplify down. So we would have 40 times the square root of 31 over 7 times 31, which is 217. Secant would just be 40 over 9. And then here we would have 9 over 7 times the square root of 31. So again, you have to take that times the square root of 31. And we would have 9 times the square root of 31 over, again, 7 times square root of 31, or 7 times 31, which is 217. So those would be our trig functions. We're going to go ahead and stop for today. If you have questions, ask them tomorrow, and then we'll go ahead and work on this again tomorrow.